Hello, everyone. So yeah, during this talk, I think during this panel, I think we'll be touching different critical points related to interoperability and bridging. I've prepared some questions, but then we'll leave some time towards the end for the audience in case you want to ask anything to our panelists. So let's maybe start with a round of introductions. If you can say like what you're working on and who you are.
Sure, yeah. My name is Lane. I am one of the founders of Everclear, formerly known as Connext, and we've been working in the interoperability space since 2019. Our latest protocol is essentially a marketplace for cross-chain liquidity where we allow transfers going from one chain to another to be netted off against like corresponding transfers going in the opposite direction.
Hey, I'm Nikhil. I lead product at the Wormhole Foundation. Wormhole is an interoperability protocol. Originally started as a Solana Ethereum bridge back in 2020, and since then has expanded greatly. And yeah, working on a lot of different products and use cases built on top of Wormhole for multi-chain use cases.
Hi, I'm Philip. I'm head of DevRel at Flare. So Flare is a layer 1 network that specializes in being able to gather data, which is either events or what's happening on transactions from different chains, and then be able to relay this to other chains. So we're an Oracle network. We also have some other oracles for prices and so on, but the main idea is to be able to having information about what's happening somewhere else and then relaying this to other chains and off-chain data also.
Hey, I'm Angus or Lamps. I'm the foundation lead at the Stargate Foundation. Stargate Finance is the one of, if not the largest bridge in crypto, or at least in DeFi. Built on top of the Layer 0 protocol. Was the first application, still is the largest application built on top of Layer 0.
Thank you. So let's start with some questions around security and decentralization. So let's try maybe to dive a little bit into the compromises and priorities that, in your opinion, we should like keep in mind while designing a bridge or a cross-chain interoperability protocol. Specifically, like thinking of like security and speed, for instance, and the role of decentralization. We know that many protocols have to keep in mind different factors, such as upgradability, or the change in the consensus of the underlying blockchains, for instance, aspects like this. So can we maybe start like sharing some point of views on this and how like you guys are approaching it within your projects?
Yeah, sure. So a lot to go into there. Yeah, I guess I'll start with upgradability. A lot of people kind of like to say that you shouldn't be upgradable, but that's a perspective that's most strongly held when nothing's going wrong. And as soon as something goes wrong, the desire for upgradability is quite strong. So I think at the stage at which interop is, where you're building on top of a lot of chains that themselves are going through upgrades and influx, that you really don't have the option to not have an upgradable system, at least in some form. I know that Layer 0 does a lot of pretty cool stuff with opt-in upgrades, and I do wish that that were more prevalent throughout the ecosystem, because I think that that's something that, for whatever reason, protocols don't really use opt-in upgrades except for Layer 0 that I know of, and that's pretty anti-pattern for the rest of the software world. So yeah, that's, I think in terms of decentralization, you can have time locks on your upgrades, you can have security councils that monitor it, and you can have it like all run by your DAO or whatever, but I think in terms of priorities, we're still a little bit far from being able to fully decentralize an interoperability system.
Yeah, I think the high-level thing that I think about when I think about this topic is giving protocols and developers and asset issuers or whoever wants to use interoperability protocols a lot of flexibility in however they want to deploy. So for example, whether they want to deploy as immutable, they should be able to deploy as immutable. If they want to deploy as upgradable, then they should be able to deploy as upgradable. And then when it comes to the underlying verification layer, I think that people should also be able to like future-proof their verification, so be able to flexibly upgrade verification in the future to use a different kind of verification if they want to, or add additional kinds of verification. So I think the higher level thing I think about generally is just there's a spectrum of decentralization, centralization, there's a spectrum of upgradable, non-upgradable, and it's important to give the people who are building on top of interoperability protocols the flexibility to choose what works for them. When it comes to the actual interoperability protocol itself, I mean, I agree with Lane's takes. Like, Wormhole is upgradable protocol. The Wormhole Guardians have never like actually upgraded Wormhole, so that sets like a good precedent. But I think it's important to have that flexibility to be able to upgrade the core layer.
Maybe I take a bit different position here. So upgradability is something you just can't get away without it. So the protocols are changing, the blockchains around us are changing, what people want is changing, but the main fact is there's a specific reason why we've set out to go on blockchain. So we wanted security, we want this immutability, we wanted this ability to know exactly what's going to happen. So, and we have to be really careful when striking a balance here by not introducing too much unknown problems that can happen at some point. So most of the hacks that happen are usually either hacks from a financial perspective or something that is made due to a human error. And each ability to make something upgradable a bit too easy might be problematic for this answer. It might be a bit of a philosophical answer, but I still think that the main ethos of blockchain is to make sure that something really works and is properly secure, and you have to be really careful when considering this. But at the end, to make people use your product, to make people be able to easily develop with it, you need to include at least some sort of upgradability inside of it and be very clear on when and under what circumstances you're going to upgrade this, because otherwise you end up with a stale product that's not going to get used. So, but still there's a huge incentive, there should be a huge incentive to make it as immutable as possible, because any changes can and probably will be exploited. So it's I'm going to go on a bit different stake here and say, be secure, you're on blockchain. If you don't want to be secure, you can use a database.
I agree and disagree with a lot of things that was said. There's definitely a lot to dive into. I don't think there's a spectrum of upgradability versus immutability. That's quite binary. You are either immutable or upgradable. I think there are parts of the system that should be immutable and parts of the system that can be upgradable. We at Stargate take a very, very strong view, and it's a similar view to the one taken at Layer 0, which is that the smart contracts that you are building upon, the primitives upon which you are building, have to be immutable. Because, I mean, if you take Layer 0 as an example, there are probably 200 applications built on top of Layer 0 today, and if you make those smart contracts upgradable, as soon as you upgrade those smart contracts, then the security assumptions of all of those 200 applications have changed in that moment in time, and that is not an acceptable risk. If you're an application developer, you should not be kind of reliant upon one engineer or a couple engineers pushing the right upgrades, and I think smart contract immutability is something that we have seen to be very, very important. I mean, the biggest example of that is, unfortunately, Wormhole, which pushed an upgrade and led to a huge massive exploit last cycle. I think like the lessons are there to be learned from, that those smart contracts have to be immutable. However, I do also agree with Nikhil that at the verification layer, you probably want to be able to future-proof your protocol. And so being able to change the the verification configurations, which you can do on top of Layer 0 by employing different DVNs, is something that is very important as well, because you can make immutable smart contracts at the same time as being able to upgrade your kind of verification layer, which I do think should be done through some sort of governance or time lock.
Yeah, so I just want to be able to respond to that. I do think there is actually a spectrum between upgradability and immutability, and I think there's upgradability at the contract layer, and immutability at the contract layer, but then there are also things that you can tune. For example, immutable contracts can still have parameters that you can tune. There are admin controllable panel or parameters. There are sort of other kinds of parameters that can always be tuned. And those also kind of add into the security assumptions of the protocol that you're building on. So for example, if you're building on an immutable protocol or a protocol that has immutable smart contracts, but still has parameters that can be tuned that can affect your deployment, then that's an important security consideration to keep in mind. And that is something that actually Layer 0 has. You can build on Layer 0 v2, which are immutable smart contracts, but they have a fee switch in those smart contracts that they can turn on and then will affect anyone who has built a protocol on top of that. So I think there is like a spectrum there, and it's not always so binary, like just because smart contracts are immutable, they are not upgradable or they don't have parameters that people can tune.
Doesn't affect the security though.
Doesn't affect the security, but it affects the assumptions that you built your protocol on.
Yeah, and we had a previous protocol where the contracts themselves were immutable and not upgradable, but we could drop in and drop out replacements, so the logic itself would be upgradable. So I agree that there is a spectrum. And I think that Layer 0 also has like an ability, and correct me if I'm wrong, but an ability to like have the applications just opt into the latest option, so they're not necessarily like perceptibly different from just being built on top of an upgradable proxy, right?
Every application can choose what their security verification stack is, and so if you opt in to verify with the defaults, then yes.
So I think something that came up, which is quite interesting for me, is like the difference between like settling for sort of forever on the on-chain interface, meaning if there is like an upgrade in the contract, for instance, because someone pushes the wrong button or because a given key gets stolen, then a bunch of applications on top will be broken immediately. Right, and another one is like the security aspect, which is the most important, which is not just about interrupting a system that used to work, but invalidating the verification and the security, like the open trust lines, basically, on the verification side. And yeah, I think something that came up is that basically, since verification is partially happening off-chain anyway, there is like some dependency there on like security, and someone needs to be able to upgrade it, right? I think we all agree from what I've heard at the beginning about like some degrees of upgradability being important for future proofness, especially on the verification. Like, let's think of hard forks of chains, making collateral inaccessible in the case of some bridges, or making a given cross-chain protocol break. So yeah, I think that's interesting, but at the end of the day, it's all about choosing the compromise, and I think we have a sort of consensus on the fact that pushing this decision out of the protocol to the end user or application is ideally the best choice when there is no alternative, and some security must be like agreed on. Would you disagree?
No, I think I would agree with that.
Okay.
I think putting that decision in the hands of the application developer is definitely the most important, I would definitely agree with that take. I don't think that's consensus, though. I think many people would probably disagree with that. And I think definitely like 2 or 3 years ago, most people would disagree with that. But I think obviously Layer 0 v2, when that was deployed, that was like a conscious decision that the security and the verification was kind of pushed, or the decision-making around it was pushed to the application developers. And I think a lot of interoperability protocols have kind of moved in that direction more recently as well.
I would maybe go even further and say that you as a protocol, you have to provide a baseline of security because the users tend to get complacent. So if you have an option of doing something really, really easy, really, really fast, with practically zero security, people are going to quickly opt in for this because of the user experience and everything else, because when nothing goes wrong, it's easy to say, yeah, everything is fine, it's sunshines and everything. And the thing is, security is like an insurance. You don't need it until there's a way to exploit it. And if you, as a protocol, allow too lax security, you run into problems when people will opt out without even properly knowing that this security might harm them at some point later, because it's just easy to start with, yeah, we're going to do this optimistically, and then, I don't know, they maybe forget to check later, or they maybe even won't implement the security at the end because the thing works until it properly breaks, and then you're screwed, like in a proper way.
Yeah, I think you said many interesting things. And specifically, I think in the first, like in the previous topic, we sort of agreed that the user should be in charge. But this has some implications and assumptions on the fact that the user cares and is online, for instance, or checks what's going on the underlying protocol, which is far from reality, from my experience at least. Let's think of something as simple as like REN, for example. REN BTC is unredeemable. It has been for a while. There are still hundreds of Bitcoins there because people didn't really take action when they were asked to. And this is the case for many other protocols where people just, even like in some of previous projects I worked on, like we try to reach out to users for years. And still, someone like wakes up maybe 3 years later saying, oh, what happened? I had this token in my wallet. I didn't see any notification. Did you ask for any user intervention 3 years ago? Oh, well. So, yeah, I think in practice, this is quite complex to achieve, but that's the best we can do. So clearly there is some user responsibility here, even if the users would like this to be completely pushed out to protocols, but yeah.
Yeah, I mean, I think that there is a difference though between users, like end users who are actually holding tokens versus like asset issuers or protocols that are building on top of interoperability protocols. Like one, the users, you can never control user behavior. You can incentivize them to do different things, but at the end of the day, if they don't see notifications or if they don't see Twitter posts that stuff is getting deprecated and they need to migrate their tokens out, they're not going to do that, right? But on the asset issuer side or on the actual protocol side, you know, I think that it's kind of a matter of proper education and being, you know, intellectually honest, not like misleading people in terms of like what the security of something actually is, because it does matter to protocols building, like it matters to protocols what the security of the interoperability solution that they're using is. It matters to them what the assumptions are, and it's important to make those clear to the people building.
Yeah, I think we'll jump back to this in a later question on like interoperability and lock-ins on tokens, because I think it's strictly related. But first, since we are discussing security, one last question on this for the panelists. I will merge a couple of questions, so if you have the opportunity to either answer to one or the other, because I think they're both quite interesting. So one is like, besides decentralization and security, do we have other like properties or concerns of those systems? Think of like legal implications or so regulation and stuff like that, or anything else that you think is kind of overlooked for the long-term viability of bridges and or interoperability solutions in general. This is one thing. And the other one is if you have like first-hand experience or just have seen something interesting around breaches, like I'm just interested to understand, is there any specific incident response methodology or anything that you think projects should really do in order to protect the protocol and their community and projects built on top when things go wrong? Because the reality of things is that many times we don't really have control of all the external dependencies, and there could be things like, you know, supply chain attacks or chains halting. Let's not even think about hard forks, right? It could be problems that affect also, in the case of wrap tokens, fungibility. So, any comment on this?
Well, I would say one thing that is a problem that doesn't really have a good solution right now is generally all of the protocols when you're going between chains, they treat the assets as like kind assets, right? So it's like, oh, if I have a USDC on Binance, then and I trade it for USDC on Optimism, it should be 1-to-1. And there's not really a good way to price those tokens, but are they the same security-wise? No, and there's not really a good way to price in that risk, and it's just mostly ignored for honestly simplicity, I think. There's like a lot of other problems that are likely more important than evaluating the liveness of those different chains. But as somebody who had a bridge to Evmos when Evmos was launching, and I don't know if you guys remember that, but they launched and then were down for like 2 weeks, months, something like that, a long time. And having like that, not built in that pricing risk between the different chain liveness was problematic, to say the least.
That's driven by UX, right? People would like to see one-to-one exchanges.
Yeah,
basically.
I mean, I think it's difficult to include it in the pricing, especially because the pricing between all these interoperability protocols is so competitive right now. It's like around, 1.5, 2 bips on Across and Stargate. So it's like factoring in then like, oh, wait, actually this like new chain has, a smaller security council and isn't quite as decentralized and their DA is off chain. So really this should be different is really a complicated thing to explain to users, and they probably don't care a ton about it, although liquidity providers on the bridges might.
Yeah, I think there's a lot of things that interoperability protocols can do to have defense in depth security. Yeah, there's a lot of layers of security that you can build into interoperability protocols. Angus tried to flood Wormhole a little bit earlier by mentioning the hack. And the hack definitely happened, but like the thing that everyone should think about is like, how did Wormhole bounce back from the hack? And how's Wormhole like built one of the strongest security programs since then? And it's by building defense in depth security systems. So it's by building things like the global accountant for the Wormhole token bridge and for NTT transfers, which is like a global balance accounting system that ensures that you can never transfer more tokens out of a chain than the amount that's been transferred in. It's building things like rate limiting. So there's rate limiting in Wormhole NTT, there's rate limiting in the Wormhole token bridge, to make sure that you can't transfer a certain number of tokens, more than a certain number of tokens in a given period of time. Then there's additional defense in depth that you can build on top of that. So there's like pausing, there's like at the protocol level, there's pausing the contracts, so giving asset issuers and admins of people who deploy Wormhole native token transfers for Burn Mint transfers, the capability to pause the contracts, giving them the capability to add additional verifiers, set a 2 out of 3 or 2 out of 2 M of N verification for token transfers. So that's just like at the protocol level. And then at the protocol level that's built on top of the interoperability protocol. But then for the interoperability protocol itself, it's fully open source. There's bug bounty programs to encourage white hat hackers. There's a very clear security policy that Wormhole contributors have put out that the Wormhole Guardians will follow in case there are existential risks. So there are multiple levels of defense and depth security. You think of them as Voldemort had 7 Horcruxes that you had to destroy all of them to be able to destroy Voldemort. It's to be able to hack Wormhole or be able to hack something like token transfers on top of Wormhole, you have to destroy all the Horcruxes that are built on top. And so I think that's an important thing that is sometimes overlooked and not too many people think about.
Well, a lot has been said, so maybe I would just like to point a few things out. So this interoperability and being able to have USDC at the same price on different networks, a lot of this at the end comes from some social expectation, which is actually really similar to what comes at the end from the hard forks. So the ability to have USDX, USDC, USDT, whatever, on different chains under the same pricing scheme also comes from the fact that exchanges treat it as the same. That pretty much there's a, let's call it a global consensus around it that seems this as the same thing, even though that we might not yet be pricing the security assumptions in, which is also one thing that might at some point get overlooked. Thankfully, it hasn't been a problem yet with bridges that At some point, a bridge will have to decide which fork of a network is the correct one. And this is not a deterministic thing usually, at least in the beginning. So it's easy to see after a few hours of a hard fork what is correct and what is not correct. But within a few minutes, you have to be very, very careful. And that's where the social consensus around it maybe can be mispricing things, but it's quite important to showcase what the correct thing is. And yeah, as with other security things, yeah, pausing is important, being able to pretty much notify everyone that something's happening, something's wrong. That's important, but again, you have to price this in your application and know that maybe at some point you won't be able to get out. And that might impact what you think that your application is able to do at all the times. So you as an application developer also have to think about this. So sure, I might not be trained to some network, but it also means that I might be forced to pause at some point just because something else bad is happening. So it's not always a win-win situation. You have to be careful about this.
Yeah, a lot has been said for sure. The USDC across different chains is, I think, as you said, kind of an issue that people have just accepted. I think generally, if there are any issues, the market will kind of sort them out. Like in theory, if you're holding an ETF in one account with one custodian, that should be priced differently to some other custodian, but they're generally priced the same, and if they aren't, then the market kind of figures that out. And similarly with like the USDC on Phantom in a previous cycle was issued by another bridge provider that eventually ended up going down, and that USDC was therefore no longer priced one-to-one, and the market kind of figured it out. Like Stargate had, I think, $10 million of TVL in that asset. The DAO ultimately voted to remove that asset as things were getting a little bit spicy, and there was some kind of arbitrage through the protocol, but nothing was that toxic. And I think, to Nikhil's point, if you build the protocols in the first place to be able to deal with these eventualities, then you're usually able to kind of figure them out alongside the market. And I think so the takeaway maybe is just that when you are building an interoperability protocol, you have to think about every single black swan event that could happen and how your protocol would deal with those eventualities, and then you have to be able to act quite fast.
Yeah, I would say, to add on to that, not only do you have to think about it, but you have to like run the drills, because like one of the big things that I think is just could be improved, and I'm interested to hear like if you guys do this with the applications that are built on top of your protocols, but do you guys run like black swan scenarios on testnet to see how the applications would respond? Because that would be a pretty big like gain across all of the interoperability protocols to be able to run those types of events. Because in a security event, it's also not great that the main channel is Twitter. And if you don't practice ahead of time, then you're just gonna like tweet with the red siren emoji. And
yeah, I think this was covered extensively in the last few days at the DeFi Security Summit. So it was nice to see that this is becoming the norm slowly. So that's great. But yeah, I guess one big issue is that you can surely test on testnets, as you said, on fake deployments, basically. You can do drills and see how the team reacts and how teams interact with each other. But it's a simulated environment, of course. So you don't have real money, you don't have real interoperability between protocols. So there are different dynamics, I would say. But still, it's a good start. The best we can do, probably.
I think you just have to, I agree. You can run all the simulations you want on testnet, but you really have to think through every eventuality, think through every single thing that could happen in every black swan, because crypto will see all of them if we haven't already. And building systems, again, if you're building an interoperability protocol or a bridge, you're building a system that ideally should enable users to move value whenever they want to move value. And if you're building a system that falls apart in a black swan event, which is probably when people need it the most, then you're not building a system that kind of scales for the industry that we're in. And so I think thinking through every single eventuality and what will truly happen if ETH, the asset, goes down 95% in one day, will your profit-seeking solvers still be around? It's difficult to know.
Yeah, absolutely. Also because in many cases, maybe applications built on top are immutable, so they don't really have the opportunity even to change stuff and have all the flexibility we are expecting, in a sense. But still, there are moving pieces because of configurations and because of things depend external components changing. So this leads to my next question, which is about long-term, let's say, viability of those protocols, and basically the big topic of like lock-ins or standardized interfaces for like long-term, usage basically of those systems. So there has been, we have seen efforts like ERC20, for instance, and a few others in that front, but more in general about like the interfaces, also for just cross-chain messaging, for instance. How do you see this lock-in problem? And it's a very hot topic, I think, also because last week, I don't know if you guys seen, but there was bad news about like a project called Degen Chain, I think, having some issues with a service provider, which basically, yeah, they didn't agree with, and basically they had issues, and the conclusion was that they couldn't continue operating their chain, which sounds a bit weird, and that they would have relaunched. So, of course, I understand the circumstances here are different. We don't necessarily have dependencies on keys and stuff like that, but the interface is different, because the interface, if someone like decides to settle, for example, I don't know, on the layer 0 interface, and for any reason in 20 years time this doesn't work anymore, then what happens? And this is a question for all protocols, not just for layer 0. So in general, how do you see that? Have you, do you have an answer? Do you think we should try to agree on yet another standard? Or like, yeah, what's the missing piece there?
Yeah, I mean, I think standards are really important, and I think that XERC20 is really useful in that it allows people to set different rate limits for different bridges, delist different bridges. The problem, though, is that you are kind of punting on like accountability for that, in that it can't go to a token that doesn't have a token owner that can like make updates. And so if you're looking at your general ERC20 token that is non-upgradable, doesn't really have like a strong owner, then you're kind of SOL. I think that goes back to the first question. That's just like, okay, do you really think that you're at a point with all of the standards across the industry where you can settle without having anything upgradable, and fully just settle on a standard, on a messaging system, on a bridge? And I personally don't think that we're there yet.
So we basically don't know yet how to do it.
Yeah, and so you better not give up the rights to upgrade your token, or, the messaging system that you're using.
Yeah, I think as we talked about before, I think that having flexibility is important. I think it's important to future-proof your protocol. It's important to be able to change verification in the future. As newer verification systems come out, and be able to have flexibility to, make sure your protocol continues running after like 10 years or however long your protocol will continue running, right? On the standards question, I think that people will always build new standards. I think maybe sometimes when I think about standards in the industry, I think that there should be a clear distinction between like what is a standard and what is a product. Like, I think that a lot of projects will come out with a product and brand it as a standard when it's not really a standard. Like, I think ERC20 is not a product. ERC20 is a standard that has enabled the widespread adoption of like tokens, and those tokens to be able to be used in a lot of DeFi protocols in a common way. I think that Everclear is a product, Stargate is a product, Wormhole native token transfers, Layer 0 OFT, XERC20, these are all products, and there will continue to be products that are not really standards. Yeah.
I guess, can you delineate between a product and a standard a little bit more?
I think that a product is like, so a standard is like something that let's see. No one is really like XERC20, or sorry, ERC20 can be used by is kind of pushed by the Ethereum Foundation. It's not something that anyone has an incentive to really grow or push unilaterally.
Except the Ethereum Foundation.
Sorry?
Except the Ethereum Foundation.
Well, I guess everyone has kind of adopted it.
Yeah.
Yeah. And different products have different trade-offs. Like Everclear has different trade-offs than Stargate. NTT has different trade-offs than OFT. And
So credible neutrality, basically.
yeah, credible neutrality.
Well, at some point, products can become standard. And we've seen this not only in this industry, but I don't know, mechanical industry, electrical engineering. You can see this, that at some point, some product is just standardized and that's it. And I think standards are really, really important. At first thing, they limit you, which is usually bad because you can not do everything through a standard ERC20 token, but they allow a uniform access to the token, uniform access both for end users, both for protocol developers, both for ordinary developers, and most importantly for tooling. And that means that people can build tools around this, I don't know, formal verification. If you know what a specific standard is, if you know how it should behave, you can have a bunch of tooling that is then accessible to everyone off the shelf, just as long as you implement this standard. And that's a huge, huge driver.
But I guess in Insight is relatively easy, right? Because clearly de facto standards means a product had 90% of the industry, if not 100%. So basically it was the winning standard. Or the winning product, if you want, in a sense. Similarly to the internet we use today, right? But yeah, but the problem probably is understanding now that we don't have it, what will be the standard, considered the standard down the line, right?
I guess I'm kind of skeptical that the next standard will be the ultimate standard. It's the ultimate meme that people post on Twitter, right? There are 14 standards today, let's make a standard to make them all one standard, and now we have 15 standards. Does that one gain adoption? You kind of don't really know. And especially in the cross-chain world, I think it's incredibly difficult for everyone in every blockchain and every EVM and non-EVM and alt-VM and whatever to come together to create one standard. And I think even within the Ethereum ecosystem, and the author of the 7683 just left, but initially the ERC 7683 cross-chain intent standard was 4 parameters. It was token in, token out, destination chain. Everything else goes in the call data, which is a standard because it's very simple, but I think at this point, after many iterations, there's 15 things in the parameters. And so you get to the point where everyone wants to have a say and everyone wants to have their piece of deadline or something in it, and it won't scale if you continue to do that. And so I think, especially in the cross-chain world, it's very, very difficult.
Yesterday, I was at an event by Protocol Labs where they were discussing APFS and how to improve the CID format, and they had the same issue, basically saying, okay, so we have a format that works today, people use it. If we had to improve it, how would it change? And basically, the same thing was being discussed, that everyone wanted their own thing in, and it will be a mess, so it's pretty much impossible to agree on it.
Yeah. I think even in single chain environments, there was some controversy on Twitter last week. The NFT standard on Solana is built by a company, and they have the upgrade keys to it, and so they were going to do some changes to the official NFT product standard that became the standard because it was 100% of NFTs, but they are able to make changes, and they're going to pull back all the rent from the accounts, and that was controversial. So in the world where there is a standard, I think, to your point, credible neutrality is probably the most important thing.
Yeah, definitely. Now, let's talk about something positive. So let's assume cross-chain interoperability is a solved problem, and we have a truly multi-chain world where smart contracts interact and so on. So in that scenario, I mean, we have seen what already works and what people want to do today, so cross-chain swaps and governance messaging, stuff like that. Is there anything that you think is non-obvious today and that we'll probably see in the future that needs cross-chain interoperability to work?
I mean, I wouldn't say it's non-obvious, but one of the things that I think will definitely have to be improved is error handling. Like when you do send call data across chains, inevitably there's a chance that it could fail. And I don't think we'll really ever get to the world where interoperability is like truly behind the scenes until we can standardize how those errors are handled and like what happens to the users if they encounter it.
That's based on the assumption that it will always be asynchronous, right? I assume.
Well, I mean, even if it's synchronous, well, I guess, yeah, it's based on the asynchrony assumption.
Yeah, it's an interesting question. I guess I maybe question like the premise of the question itself, as in what does it mean to have a truly multi-chain world?
Well, maybe let me try to clarify it. So today we see a trend of new chains, layer 2s, layer 3s being launched. And in many cases, I mean, I speak with many of them and they all say, yeah, we are in discussions with bridges because we don't want to be isolated. So we don't really have a direct path to go from chain A to chain B. So let's assume this is a problem of the past and that all new chains, any chain that gets launched can potentially like communicate with any other chain. So this is the future scenario.
Yeah, I guess maybe I think it's unclear how that becomes a problem of the past and how that just gets like totally solved. And so it's kind of unclear to say, it's kind of difficult to say it's unclear what the solution to that will be. And so to me, it's unclear what the missing things in that solution would be. I think that they're going to continue, it appears that there are going to continue to be a lot of chains. It's tough to say how many chains are going to exist in like 5 to 10 years from now. But there will always be chains that I think struggle or need to find bridges and connective tissue to the rest of the crypto ecosystem, and there are going to be different ways to accommodate for those bridges. And I think that goes back to modularity and flexibility. Like today, maybe, you know, for example, Wormhole doesn't support one chain. They can use the canonical bridge to connect to the rest of the crypto ecosystem. And in the future, when Wormhole supports that chain, they can use Wormhole, or similar thing for other kinds of intense protocols, whether it's Stargate or Everclear or something else. You know, there are always going to be new chains, and they're going to need ways to connect to the rest of the crypto ecosystem. And I don't think that multi-chain is just going to be like solved like that.
Well, I think one of the main problems is that, okay, let's assume it's solved and everything. So one thing is if you have this quadratic problem of bridges, so every chain connected to every other chain, you have this is just a hornet's nest. You don't want to poke into it. We're going to die if we try to solve this. And then the other is that once you have a new chain, there's a whole bunch of questions. When do you trust the block to be mined? There's this asynchronous problem when even on Ton, you have asynchronous call within the chain. So how do you make this really fully interoperable? It's a proper non-trivial thing, specifically from the end user perspective. So I'm sending funds from Polygon to some other chain. Why does it take so much time for the bridge to confirm them? Well, here's a white paper. You can read it and it explains why you need to wait 20 minutes. I think this thing will take quite a while to be solved, not only from a developer's perspective, but also from the end user experience to be able to just forget what chain you're operating on.
Yeah, I think for that final point, to forget what chain you're on, you also have to treat the block space as fungible. And I think a lot of applications that launch today will launch on one ecosystem and then try and communicate with other ecosystems. I think in the very near future, a lot of applications will start by launching on like 10 chains at the same time and treating that block space as fungible, because ultimately launching these L2s and L3s is to like improve the amount of throughput that you can have as a builder and a user. And so if you launch on 10 blockchains at the same time, you can utilize all of their throughput and then use something like layer 0, for example, to communicate between them.
Yeah, and I also agree with this point as well, which is like new chains are still continuing to be launched with new kind of ways of working, like Ton. There's Solana, SVM. There's like, there will probably be more kinds of VMs that get launched in the future. There will probably be new kinds of EVMs with different block space assumption or different block time assumptions, different finality assumptions, all these things. And so I also don't think that multi-chain is just this problem that can be solved super simply because chains with different assumptions at the underlying consensus layer will need to have different kinds of bridges.
Thank you. So we have run out of time, but maybe we can take 1 or 2 questions from the audience. So let's thank all the panelists. Thank you.
Thank you.